Good morning or good afternoon. It's Miss Bauer here, and today we're going to talk about circles. Now, I'm sure that you know what a circle is, and a circle technically is the set of all points that are equidistant from a point on a plane. So it's all of these points that are equidistant from that center, right? That's a circle. And the center is the point in the middle where all of the other points are equidistant. You've heard of radius before, you've heard of diameter, but today we're going to get into some new words like a chord and a secant and a tangent, which you've heard of a tangent before in like sine, cosine, tangent, but there's tangent on the circle. Some angles, and then we'll talk about arcs in a little bit. Now, instead of reading through all of these definitions, what we're going to do is we're going to actually draw a visual of these definitions on that colored formula chart. So if you take a look at the back of this, what we're going to do is we're going to draw some of these words in. So the first, we know what a circle is, we have that, but the first thing that we're going to do is we're going to give this circle a center. So I'm just going to put a point in what is closest to the middle. It might not be perfect, but we call that a center. And then all these other points are equidistant from the center. And you've seen this next word before too. If I go from the center out, that distance right there, that's called the radius. So from the center out, and this is also a radius, that's also a radius, that's a radius, that's a radius. There's several that I can draw. It doesn't really matter. I'm going to go ahead and draw one right there, and I'm going to label that radius. Now, that next word, chord, is just a segment with endpoints on the circle. So, if I go back, a chord is just a segment, and it has endpoints on the circle. So, like I put endpoints on the circle, connect them, that's a chord. I put endpoints there, connect those, that's a chord. From there to there, that's a chord. So, a chord is just a segment that has endpoints on the circle. So, I can pretty much draw that chord wherever I want to draw it. I'm going to draw it up here, and I'm just going to label it chord. And I like to think of a chord as it cuts the circle. Like a chord will it chops off that circle. It just cuts. That's it. It doesn't go past it. It just literally like cuts from corner to corner. Think of it that way. Now, a diameter is a chord. A diameter is a chord. It's just a special chord that happens to pass through the center of the circle. If you think about it, a chord's just a segment that stops on the circle, and that is exactly what a diameter is. It just happens to pass through the center. So you could draw your diameter that way if you wanted to. You could draw your diameter that way if you wanted to. It doesn't really matter. But the diameter is just a chord, and it has to pass through. So there's our diameter. So circle you've seen, I'm just going through that list. So circle, center, radius, chord is new, diameter is old. And the next one says secant. Now, a secant is a line that intersects the circle at 2 points. So while the chord cuts, the secant sees through the circle because it's a line. So that's how I like to remember it. So a secant will go past the circle. It's a line. So we'll typically have arrows. Sometimes it won't have arrows, but it goes past the circle. And that's a secant. The secant could be a line. It's most of the time a line, but it could be a ray or something else. But the secant sees through the circle. It goes past it. So remember that a chord cuts, but a secant will see through the circle. Okay, and then our next word is a tangent. And if you go back and read that definition, a tangent is a line, ray, or segment that intersects the circle at exactly one and only one point. Okay, this is not a tangent. Like drawn like little like hairs on a circle, that's not a tangent. A tangent is a line or a ray or a segment, and it just taps the circle. It just crosses the circle one time. So if I'm going to sketch out a line here, that doesn't intersect the circle. That's a secant. Now that I'm in the circle, that's a secant. But if it were just going to tap it, if it were just going to intersect it one time, so think of a tangent just tapping, touching like one time, that's a tangent. It could be a line, it could be a ray, so I could do like that, make it a ray. I could make it a line, or it could be a segment. But the key thing about a tangent is that it only taps, or touches it one time. So I like to think of a tangent that it taps a circle. Now, any point on the exterior of the circle we'll call a point of tangency because it could tap. So like that would be a point of tangency. Technically, this over here would be a point of tangency. But like any point on the exterior where I could like tap the circle, we call that a point of tangency. So some of these words are new. So just remember, like a chord cuts the circle. It's a segment that cuts. A secant's like a line that sees through. And a tangent will just tap the circle. You've heard radius before. You've heard tangent before. So now we're going to talk about this next word, which is a central angle. A central angle is just an angle whose vertex is at the center of the circle. So this right here, we already have one. That is a central angle because the vertex is the center of the circle. This is not a central angle because the vertex is not at the center. This is a central angle because the vertex is at the center. This is a central angle because the vertex is at the center. There's so many central angles in here. I could really draw whatever I want. I'm just going to highlight this one that I already have that was made with the radius and the diameter. So this right here, that is a central angle. So this right here, that's a central angle. Central angles just have to stem from the center of the circle. So the vertex has to be at the center of a circle. Now, angles open up to what we call, so that's a central angle. Angles open up to what we call the arc. And an arc is just a part along the edge of the circle. Like that's an arc right there. This is an arc right here. Not a tangent, but like an arc will have an actual measure of it. And it's the part that curves along it. So I like to think of, there's like two different parts that we're going to get into in a little bit, but there's arcs and there's what we have called sectors of a circle too. So I'm going to sketch out this same circle. That would be a central angle right there. So this arc part, the arc is that part right there along the edge of the circle. That's what's called your arc. And we're going to get into solving and all sorts of stuff with these in a little bit, but if you don't know the vocabulary, it's going to be really, really hard to do that. So that's an arc. I like to think of the arc like the crust of a pizza. It's like the perimeter, it's on the edge. Well, arcs are formed from central angles, so there's your arc right there. But central angles also have what we call sectors, and that sector is that filled in, it's that area right there. So that's called a sector, which isn't on our vocab list, but it's one to know. And this sector is like the slice of the pizza. So the sector, whenever we have that central angle, the sector is that like shaded part, that's your slice, and the arc is like that crust along it. Well, we have measures. We can actually have like values and measures to all of these. So for example, if I told you that the central angle was 30 degrees, then the measure of this arc would be 30 degrees. And that gets us into minor arcs and major arcs. So if we go back and we take a look, a minor arc is an arc that's smaller than half the circle, and it has to be less than 180 degrees. If you think about it, full circle is 360, so half of that would be 180. So a minor arc will be less than 180. A major arc should be more than 180 because it's major. And a semicircle is what we call the half circle. It's the arc that is half of the circle and measures exactly 180 degrees. And because we have these values, we can have congruent circles and we can have congruent arcs. So going back, taking a look, this right here, this would be a minor arc. So I'm going to go ahead and highlight that and call it arc. But we know specifically that that's a minor arc. And minor arcs would typically be written with 2 letters. So like if that's AB, then I would call that minor arc AB, just like that. A major arc takes up more than half. So if I actually went around right here, this would be a semicircle. So if I did that, that would be a semicircle. But if I kept going, now that would be a major arc. And major arcs will typically have 3 letters because they'll go through like 3 points on the circle. But that would be a minor arc. And you've heard of semicircle before. It's like there's your semicircle, half of it. So semicircles have a measure of 180 degrees. They're also where the diameter is. Now, there's one more thing that we're going to talk about that wasn't on the list, and that's that we have inscribed angles and central angles. So this is a central angle. The angle from the center, if I fill that area in, that was called a sector, that's called an arc. But we also have these other angles that are called inscribed angles. And they don't really have anything to do with the sector or the central angle. An inscribed angle is an angle where the vertex is on the edge. So this right here, and then if I went up like that, that's an inscribed angle because my vertex is on the edge of the circle. This is not an inscribed angle, but this is an inscribed angle because the vertex is on the edge of the circle. So as long as the vertex is on the edge of the circle, so just like that, there's my vertex on the edge of a circle, that's your inscribed angle. So what we'll really start out with is central angles and minor arcs, major arcs, all of that. And then we'll dive into inscribed angles and some of these new vocabulary words. So taking a look at this particular example, it says if AC is a diameter. Well, that's important to know because if that's the diameter, then that cuts that circle so that this part is 180 and this part is 180 because the measure of a full circle is 360. So wherever that diameter is, AC is the diameter, that diameter is going to cut this circle so it's 180. And you'll typically have more than one diameter. In fact, I see another one. I see B to E is also a diameter. So it says find the measure of angle BFC. So if I'm finding the measure of angle BFC, well, if you notice right there, they cross. If the measure of this angle is 97.4 vertical angles, the measure of angle BFC would be 97.4 degrees. So those are vertical angles, they cross right there. What I want to do is I want to find some other parts. So what if I said find the measure of arc CD? Well, the measure of arc CD would go with whatever that angle is right there. And if this is a diameter, then it means that all of this should add up to 180. So I can find that angle, I just need to figure out that angle, and then that tells me what that arc is. So this angle measure and this arc measure are the same. The central angle and that matches. So like if I asked you, what's the measure of arc DE? Well, the measure of arc DE we know because DE is the arc that goes with that angle right there, which is 52 degrees. So to find the measure of arc CD, I know that half the circle is 180. I know that's 97.4 right there. So I'm going to do 180 minus 97.4 minus 52. So I'm going to do 180 minus those. And that's going to tell me that missing piece. And that's 30.6. So what's the measure of arc C to D? That would just be 30.6. And if I asked you for the measure of angle CFD, that would also be 30.6 degrees because that's the central angle that goes with that arc. Now, I'm going to ask you a few other questions. If I asked you, like, what would be the measure of arc BC? What would be the measure of angle AFB? What would be the measure of arc AC? And if I asked you what would be the measure of arc ACB, that changes things up a little bit. So minor arcs have 2 letters. Major arcs have 3 letters. So if I wanted to know what was ACD, then I would trace it from A to C to D, and that takes up more than half. That would be a major arc. But if I just said AD, I'm not going to take the long way. If there's only 2 letters, we take the shortest distance. So for CD, I didn't go around that way. If there's 2 letters, I take the shortest distance. So let's take a look at some of these. If I asked you for the measure of arc BC, well, arc BC goes with that angle right there. That would be 97.4. If I asked you for angle AFB, well, there's a few ways that we could find it. I know that that's a diameter, so I could subtract from 180. I also know vertical angles again, so I can do that. I'm just going to do 180 minus 97.4. And because this is a diameter, I can just do 180 minus that number, and that's going to tell me that missing piece, which is 82.6. Okay, and if I ask you for arc AC, well, that's half the circle. That's on the diameter, so that would just be 180 degrees. And if I asked you for arc ACB, so ACB, that's the wrong way. ACB would be A to C to B. And notice that it's 3 letters, which makes it a major arc. So A to C to B means I'm going to add up all of those parts. And there's a few ways to do this one. I can do 360 minus the part I don't have, so minus 82.6, because I'm doing everything in the circle, which is 360 minus that piece. Or I can add up all those little parts if I prefer to do that. I'm going to give you a minute, so pick an option, whether you're adding or subtracting. We'll see if we get the same answer. Well, 3 letters is that major arc. That would be 277.4 degrees, which is more than half, so that's what makes it major. So if I asked you for, let's do the measure of AD, of arc AD, remember, I wouldn't go that way. I would take the shortest distance. But if I said the measure of arc ACD, well, now I'm going to take the long way around. That would be a major arc, and 2 letters would be a minor arc. Now, we're going to review some other things like circumference and area and all of that with circles, and get into some more of the vocabulary. But keeping in mind that those central angles and those arc measures are exactly the same. We'll see you in the next video.